Designing EMI shielding isn't just about mitigating interference. It's about doing so in a way that meets strict and evolving regulatory requirements, such as standards from CC Part 15 to MIL STD 461. Navigating the landscapes of EMI compliance can be overwhelming. This is especially true when standards vary by industry, geography, and device type. Missing the mark can mean costly redesigns, or delayed certifications, or even product failure. Understanding these standards upfront can drastically improve your performance and efficiency of your shielding solution. And when paired with the right materials, such as precision-engineered woven wire mesh, meeting those standards becomes not just achievable, but a repeatable process. So EMI shielding requirements are rarely a one-size-fits-all. Regulatory standards play a major role in how electronic systems are designed, especially when those systems operate in environments where reliability and safety are non-negotiable. The challenge isn't just understanding what each standard says, it's about designing around them in a way that's both effective and efficient. Key regulations like FCC Part 15, CISPR, MIL STD 461, and RTCA DO 160 set the bar for electromagnetic compatibility, each with their own scope and testing methodologies. These standards dictate everything from acceptable emission levels to shielding effectiveness and grounding protocols. Depending on the application, failure to comply can lead to failed inspections, withheld certifications, or total product disqualifications. That's why understanding the why behind each standard is just as important as understanding the what. Design engineers need to know not only what threshold must be met, but how material selection, enclosure geometry, and integration strategies impact compliance outcomes. The earlier these requirements are factored into the design, the fewer costly surprises arise downstream. So whether you're building for commercial electronics, aerospace platforms, or industrial automation, aligning your EMI shielding strategy with the right standards from day one is essential for getting to market quickly and making sure you stay there. So behind every EMI decision lies a specific set of regulatory requirements, and meeting those targets often depends on how well your material and design choices align with the demands of the environment. Agencies like the FCC in the US, the CE in Europe, and various military or aerospace bodies enforce compliance through a range of well-defined standards. While most EMI standards share the goal of minimizing electromagnetic interference, the paths they take to get there can vary widely. FCC Part 15, for example, governs unlicensed emissions in commercial products sold in the US. It's a fundamental requirement for anything from consumer electronics to lot devices, placing strict limits on both radiated and conducted emissions. MIL STD 461, on the other hand, sets far more aggressive thresholds for military platforms, often in harsh and variable environments, requiring shielding solutions that go beyond basic conductivity. These differences have a direct impact on what materials perform best in each use case. A commercial product might prioritize cost efficiency and ease of integration, making lightweight conductive coatings a logical fit. In contrast, military and aerospace industries often call for woven wire mesh when durability, frequency range, and grounding integrity are paramount. But what's consistent across all industries, however, is the need for shielding materials that are verifiable, repeatable, and testable. When regulations demand documented performance, choosing a shielding solution that supports standardized testing and validation becomes non-negotiable. The more precise the material performance, the more confidently you can approach the compliance. So as EMI shielding requirements continue to evolve, materials that offer both performance and adaptability are becoming essential. Woven wire mesh has emerged as one of the few solutions that consistently meets the demands of modern EMI standards, from FCC and CE to MIL STD and RTCA DO 160. One of woven wire mesh's greatest strengths is its broadband shielding effectiveness. The structure of interwoven metallic wires creates a conductive path that can reflect and absorb EMI across a wide range of frequencies, from low megahertz to high gigahertz, without sacrificing airflow, weight, or form factor. This makes it especially suited for applications in telecommunication, defense, medical, electronics, and aerospace, where consistent performance across operating environments is critical. Equally important, though, is testability. Unlike coatings that may degrade over time or require destructive testing to verify compliance, woven wire mesh can be evaluated non-destructively, and its performance can be precisely molded and predicted. This reliability not only supports compliance during prototyping and manufacturing, but also improves long-term traceability during audits or product recalls. Finally, the inherent customizability of woven wire mesh including weave type, wire diameter, material alloy, and mesh count, means that it can be tailored to match the exact specifications of the EMI standard that's being targeted, ensuring more accurate and consistent compliance. Thanks so much for watching. If you have any questions, click on our Talk to Us button to get in contact with our many experts on woven wire mesh. And if you'd like to learn more about woven wire mesh or our many products, we have a learning center filled with written and video content to make you an expert. We also have a YouTube channel. And don't forget to click that subscribe button and ring that bell to keep up with all things W.S. Tyler. Once again, my name is Andrew Kotlar, and I'll see you around in the next video. Bye for now.